Moving on here, we're going to take a look at type conversion. Remember that integer division does not net you the result that maybe you're expecting. So here in the example, we have an integer value for pizzas. So I have 24 pizzas. Seems like too many pizzas to me, but whatever. And here I have a number of students is 10. So you'll see, actually, before we continue on here, this line number 4 has a comma separated value for assignment and declaration, right? So the assignment is the equals 10, the declaration is students, which is of type int. So now I have a double for slices per person. Now, slices per person equals pizzas divided by students. Now, this is what I'm going to do. We're just going to go ahead and run this now. And what we're going to do is we're going to run into the problem that is integer division, because I have pizzas, which is an int, divided by students, which is an int. The result of that is what? 2.4, right? Because if I have 24 divided by 10, it's 2.4. I'm sure you're okay with that. The problem is here, that is an integer, and integers do not have decimal precision. So that 0.4 simply goes away, and the result that's stored back here as a double, you can see here in my output window, is 2.0. This is a problem. So we need to be able to avoid that. The way we would do this is with typecasting. This line right here, line number 13, is how we can show that typecast. And actually line 14 is where we'll show the output one more time. A little getting to know your replit here is on a Windows PC, if you do Control / and on a Mac, if you do Command / you can comment in or comment out either one line of code. So that is one line, and I just, any place in the line, I simply say Control / or Command /, or if I highlight a bunch of lines, I can say Control / or Command / and comment them in or out. Let me give you a word of advice here, especially in the beginning. I know that a student is going to want to delete lines of code. When something doesn't work right, delete it and start from scratch. It doesn't work again, delete it and start from scratch. The problem is you're going to forget what led you to that first decision over the, all those deletes. Don't do that. Comment the line out instead. That way you can see what the previous example was. You can see that, okay, something was wrong here, and it's easier to work your way backwards to there. I will tell you honestly, it is much faster to fix a line of code than it is to start a line of code from scratch. So just think about that. So here we have slices per person, exactly the same way it was up here on line number 7. But this time we are casting as a double. So that's what this parens here does. It says cast the resultant here, pizzas divided by students. So we work from right to left here, going this way, which is a little bit backwards. So we take the result of pizzas divided by students, we save that as a double, and then that value is stored here in slices per person. Here on line 14, we're going to output that. So if we run this, what we should expect to see is the first, there we go, the first output says 2.0 because this one relied on integer division. Here on line 13 and 14, which is our second output over here, because we cast the answer of pizzas divided by students as a double. So this becomes 24.0 divided by 10.0 equals 2.4 equals 2.4. And that's how we get the correct output over here. So really, this is going to be the most valuable to you when you are doing integer division. But if you find that you need, for whatever reason, highly specific numbers, so think about the double. Remember the crazy number of precision we get to have here? So if we need to cast a float, for example, into something that is more precise, we would do exactly this. A float for pizzas, a float for students can be cast as a double and then saved into a double variable. Don't worry, you'll see more of these, and it'll make more sense the more we get to use them.